Hello guys, so good day everyone. Okay, right now I will discuss, I'll give you an information prior to the rational root of Theorem. Okay, so here we need to have the roots, and we will find the roots that will make the polynomial function equal to zero, or has the so-called remainder zero. So just like this example, the number one. Okay, find all the roots of the function. So, say for example, we have the f of x, or the function of x is equal to x cubed minus x squared minus 10x minus 8. So, the question is, okay, or the question to yourself is that what would be the root, possible root, or number that if we substitute to the all x's here will give us 0. So first take a look at the constant and ignore the sign. Just take a look at the constant and the leading coefficient of this degree, or of the degree, or the highest exponent. So I'll write here the a, and also the leading coefficient of this leading term. So just the one. Now, okay, after that, okay, you already have your one. Okay, think of all the factors of 8. Okay, numbers that will give you a zero remainder. So there is 1, a factor of 8, 1, 2, 4, and 8. Also, same with the constant, which is same with the leading coefficient. So the factor of 1 is 1. Okay, so all you need to do is that, okay, I'll copy that one, I'll copy this one here. Okay, so the possible rows, so the possible rows comprise of positive and negative. So we have, I copy the 1 here, 1, I'll copy the 2, I'll copy the 4, and I'll copy the 8. Then the one here, I'll make this as the denominator. So 1 all over 1, 2 all over 1, 4 all over 1, and 8 all over 1. So this set composed of this elements 1 all over 1, comma 2 all over 1, comma 4 all over 1, comma 8 all over 1. Okay, so you can simplify also this 1 all over 1. This will give you 1, this will give you 2, 4 all over 1 is 4, 8 all over 1 is 8. So we have positive and negative 1, okay, possible roots 1, comma 2, comma 4, comma 8. So these are the possible roots. So if you have the possible roots, that can be a positive 1, 2, 4, 8, and also can be a negative 1, 2, 4, 8. So, okay, the challenge, or the uh, challenge here is that, okay, we need to have this trial and error. We need to substitute all the values, all the positive values and negative values of this 1, 2, 4, 8. So if you substitute and you get the 0, so for example the 1, you substitute positive 1 and you get 0, therefore that root is uh, the rational root which we are looking for. Okay, so and so for example you substitute 1 and you did not get 1, so therefore you did not get the 0, so therefore this one is not the possible root of this polynomial function. So you need to have that trial there. So we'll try. So for example, this one, we substitute 1 to all of the x's here. So we substitute 1, so this will be the result. 1 raised to 3 minus 1 raised to 2 minus 10 times 1 minus 8 is equal to 0. So I'll write 0 here because, okay, we want to have the value of 0, we need to have the value of 0. So, what is 1 raised to 3 is 1, minus 1 square is 1, minus 10 times 1 is 10, minus 8. So 1 minus 1 is 1 minus 1 is 0. Okay. Then 0 minus 3 is negative 10. Negative 10 minus negative 18. So this is negative 18 is not, okay, negative 18 is not equal to 0. Therefore, so this x is equal to 1, or this x plus 1, or this x is equal to 1, or this x plus 1 is not the root or the rational root. Alright, so here negative 18 is not equal to 0, so this x is equal to 1 is like the rational root, because you didn't get the 0 that will make the polynomial function equal to 0. So negative 18 is so different from 0, so that's why this x is equal to 1 is not the rational root. So you try the opposite sign, so negative 1, so x is equal to negative 1, your substitute negative 1 cube, minus negative 1 squared, minus 10 is negative 1, minus negative 2. So negative 1 cube is negative 1, yeah, minus negative 1 square is 1, minus that is negative 1, negative 1 is negative 10, so this will be a positive. Then minus the conservative upper calculating, and you will get the 0. So therefore, the thing that the polynomial function that will make that 0, so this is the negative 1. So now we already have the first root, or the first 0, so x is equal to negative 1. So upon solving for, or trying to solve the remaining 2, or the negative 2, or the negative 4, or 8, or the negative 8, so the correct answer, okay, so but you need to try all, but here I will write the correct answer now. So we already have the negative 1 upon solving, negative 1, the negative 2, and positive,